In this video, we're going to talk about the basics of the .NET's built-in dependency injection container. First, let's go over some theory and then see how to implement practically in our demo. The Microsoft.Extensions.DependencyInjection nuget package contains all the components required for .NET's built-in DI functionality. This nuget package references another nuget package called Microsoft.Extensions.DependencyInjection.abstractions, and this package contains the following types: iService collection, service descriptor, and IServiceProvider. iService collection is a contract for a collection of service descriptors, so it is basically a type that is used for registering services. Service descriptor represents a single service registration with the DI container. So it describes a service with its service type, implementation type, and lifetime. It can also describe implementation factories and instances. And finally, IServiceProvider represents the .NET's dependency injection container. It is used to resolve or create instances of services whenever needed. Back to the solution. I have added a console application project to the solution. And let me add the dependencies for the business logic layer and data access layer. Also, we need to install the Microsoft.Extensions.DependencyInjection nuget package. So go to Tools, NuGet Package Manager, and Package Manager Console, and set the default project to our console application, and say install-package Microsoft.Extensions.DependencyInjection, and hit enter. Open the program.cs class file. Let me remove the boilerplate code. I'll start by creating an instance of service collection. So say var services equals new service collection and bring in the namespace. This service collection type implements the iService collection interface that we talked about earlier. And note that since we are creating a brand new instance of service collection, this services variable does not have any services to start with. But we can use various APIs for adding services to the service collection instance. These are lifetime named generic extension methods like add singleton, add scoped, and add transient that we talked about in the earlier section of this course. So let's register our book service class and iBook repository implementations as scoped services like we did earlier. Now, we will talk about the different ways of registering services in the next video, but note that these methods are just convenience methods that internally create a service descriptor instance and adds it to the service collection. For example, the call to add scoped of iBook repository, book repository is equivalent to the following code: var service descriptor equals new service descriptor, passing in type of iBook repository, type of book repository, and service lifetime dot scoped. And finally, call the add method, passing in the service descriptor instance. To use the add method, we need to bring in the extensions namespace. So this is the equivalent code of the above method call. Let's get rid of this code. Once all the services are added, we can use build service provider to create the .NET's dependency injection container. So we can say var provider equals services.buildServiceProvider. BuildServiceProvider is an extension method on the iService collection type that, when called, returns an implementation of iServiceProvider. As we can see from IntelliSense, provider is of type service provider, and if we explicitly type our variable to service provider and go to its definition, we see that service provider implements the iServiceProvider type that we talked about earlier. So this iServiceProvider implementation represents the .NET's built-in dependency injection container, and it can be used to resolve or create instances of services when needed. Let's go back to our Blazor web app project and comment out the lines from the previous section of this course. If we expand the project's dependencies, frameworks, and Microsoft.ASP.NET Core.app reference, we see we have the two nuget packages installed automatically: Microsoft.Extensions.DependencyInjection and Microsoft.Extensions.DependencyInjection.abstractions. Now, when we call web application.createBuilder, passing in the command line arguments, this method called returns an instance of web application builder, and this builder object exposes a services property which is of type IServiceCollection. Since we are not creating a brand new instance of service collection like we did in our console application, the services property itself comes with a set of services already registered by the ASP.NET Core framework. These services are called framework provided services, and some of them are iWebHost environment, iHTTP context factory, and iLogger. Now we can append to these services by registering our book service and iBook repository services like so. Finally, when we call builder.build, that returns an instance of web application, and we can say var provider equals app.services. This services property is of type IServiceProvider, and it represents the .NET's built-in dependency injection container that contains all our previously registered services. Now, our addBook component uses property injection to inject an instance of book service. So in our web browser, when we navigate to /add-book and the addBook component will be rendered for the first time, at that point our component will be instantiated and property injection will be done. The framework internally uses the iServiceProvider implementation to get a required service of type book service. Since we already registered the book service type in our dependency injection container, the DI container can supply a new instance of that service for us. But wait, the book service class has a constructor that accepts an iBook repository as a dependency. So once again, the iServiceProvider.getRequiredService is recursively called for the constructor parameter. And since we had registered iBook repository service in our service collection, the DI container will supply an instance of book repository to the book services constructor. So this way, each requested dependency requests its own dependencies. The dependency injection container creates or resolves the dependencies in the graph and returns the fully resolved service. This entire set of dependencies that must be resolved is typically called the dependency tree, dependency graph, or object graph. In the next video, we'll talk about the different ways of registering services.